Welcome back! CSEC Chemistry, January 2023, Paper 2, Questions 4 to 6. Share and subscribe for other upcoming content. Let's begin. Question 4A, Part 1. Graphite and diamond are two allotropes of carbon. Define the term allotrope. Allotrope is the existence of an element in any two or more different physical forms with different arrangement of atoms in the structure. Part 2. Draw the lattice structures for diamond and graphite. Diamond consists of carbon atoms. Each carbon atom is covalently bonded to 4 adjacent carbon atoms in a tetrahedron shape. Then you are going to connect a carbon atom to each carbon atoms at the base of this diagram. Draw 3 carbon atoms and bond all 6 carbon atoms at the base of the new diagram. To finish the diagram, attach 1 carbon atom to alternate carbon atoms at the base of the diagram. Lattice structure for graphite. First, draw a hexagon with carbon atom at each vertex or each corner of the polygon. Then attach 2 hexagons to the right of the previous one. Draw a replicate or another structure seen on the screen at the bottom, facing or mirroring each other. Lastly, draw broken lines to connect the carbons facing each other. These broken lines represent weak van der Waals forces. B. Like metals, graphite can conduct electricity, but diamond cannot. Part 1. Explain, in terms of bonding, why graphite conducts electricity, but diamond does not. The answer: graphite conducts electricity because each carbon atom is bonded to 3 carbon atoms by covalent bonds, and the 4th electron is delocalized. Mobile electrons allow the conduction of electricity. However, diamond does not conduct electricity because there is no mobile electrons, since each carbon is covalently bonded to 4 other carbons. Part 2. Describe the bonding present in metals. Metals contain metallic bonding. This is an electrostatic attraction between closely packed positive metal ions known as cations and delocalized electrons. The cations are arranged in layers. The electrons lost to form positive ions become mobile and move freely throughout the layers or lattice. C. Sodium chloride is solid at room temperature. Part 1. Sketch the lattice structure for sodium chloride. Sodium chloride has a face-centered cubic array, where one unit, as seen on screen, has an octahedral geometry where one sodium ion is bonded to 6 chlorine anions. For the lattice structure, first, draw 3 squares facing each other. It is best to draw squares and not rectangles, although you are seeing rectangles on screen. Then draw lines to connect all 4 vertices or corners. Draw chlorine anions at the vertices of this diagram. At the side of the diagram, draw sodium between each chlorine ions. Draw a rectangle in the center of the diagram. Ensure that the vertices are touching the face and the back of the diagram. Add sodium ions to the vertices of this new rectangle. Notice the sodium ions are between chlorine anions. Draw chlorine anions in the center between each sodium ions. Draw another rectangle touching the sides of the diagram. Add sodium ions between the chlorine anions. And draw chlorine anions between sodium ions. Lastly, draw the unit in the middle to complete the diagram. Part 2. Which type of bonding exists in sodium chloride? The answer is ionic bonding. Question 5. A. Ethene undergoes a halogenation reaction to form 1,2-dibromoethane. Part 1. Draw the fully displayed structure of ethene. Based on the name ethene, eth is the prefix for 2 carbons, so you're going to draw 2 carbons with the space between them. The ending ene represents a double bond between the carbons. Lastly, you are going to attach hydrogens so that each carbon has 4 bonds. Part 2. Write the molecular formula for 1,2-dibromoethane. Ethane indicates that this molecule is an alkane having 2 carbons. The general molecular formula for alkane is CnH2n plus 2, where N represents the number of carbons. So the molecular formula for ethane would be C2H6. Dibromo in the name of the compound indicates that there are 2 bromines, replacing 2 hydrogens. Therefore, the formula C2H6 minus 2 hydrogens. The molecular formula is C2H4Br2. Part 3. Draw the fully displayed structure of 1,2-dibromoethane. First, draw 2 carbons single bonded to each other, and each carbon should have 4 single bonds. 1,2-dibromo means that there are 2 bromines. However, 1 bromine is attached to carbon 1 and another bromine is attached to the other carbon, carbon 2. Then you are going to draw hydrogen atoms at the remaining bonds to complete the structure. Part 4. State whether the halogenation of ethene is an addition or substitution reaction. The answer is addition reaction. B. Dibromomethane can be obtained from methane. The reaction takes place in 2 steps. Part 1. Write balanced chemical equations to show each step in the formation of dibromomethane. Step 1. Methane. Chemical formula CH4 gaseous state. You have to write the state symbols. Plus bromine Br2 gaseous state. These react in the presence of UV light, so you should write UV light above the arrow. The products are bromomethane, also known as methyl bromide, CH3Br gaseous state, plus hydrogen bromide, HBr gaseous state. In step 1, one of the methane's hydrogen atoms is replaced by a bromine atom. Step 2. Bromomethane CH3Br gaseous state plus bromine Br2 gaseous state react in the presence of UV light to produce dibromomethane CH2Br2 gaseous state plus hydrogen bromide gaseous state. Part 2. State whether the halogenation of methane is an addition or substitution reaction. The answer is substitution reaction. C. Ethene and propene are typical monomers which are used as starting materials for making polymers. In forming polymers, ethene and propene undergo addition polymerization. Part 1. Define the term polymer. Polymer is a macromolecule, meaning large molecule, which are made up of many linked monomers. Monomers are simple chemical units. Part 2. Define the term addition polymerization. Addition polymerization is a process in which monomers are chemically joined at the double or triple bonds to generate a polymer without forming other products. Part 3. State one use of each of the following polymers. Polyvinyl chloride. This is used in the production of pipes, medical items like oxygen masks, or you could write production of wire and cable insulation. Teflon. This is used in the production of waterproof fabric, or you could write production of non-stick cookware. Question 6. A. The most abundant gas in the air by volume is nitrogen. List one physical property and one chemical property of nitrogen. A physical property is colorless, or you could write odorless or tasteless gas. A chemical property is chemically inert under normal conditions, or you could write Nitrogen reacts with some metals to form metal nitrides. B. When gases are produced in a school laboratory, there are three main methods in which they can be collected: upward delivery, downward delivery, and displacement of water. Part 1. List the two factors that should be considered when choosing an appropriate method for the collection of gases in the laboratory. The answer: if the gas is soluble or insoluble in water. Another factor is the density of the gas. If the gas is denser or less dense than air. Part 2. State which one of the three methods is best suited for the collection of ammonia gas in the laboratory. Explain why each of the other two methods would not be appropriate. Ammonia is best collected by the method upward delivery, also called downward displacement, in a glass jar. Downward delivery would not be appropriate because ammonia is less dense than air. Therefore, ammonia would rise and escape. Displacement of water would not be appropriate because ammonia is highly soluble in water. The gas will dissolve in water and cannot be collected. C. Draw a labeled diagram of the apparatus which could be used for the preparation of dry ammonia in the laboratory. Ensure that you identify on your diagram the location of the reagents to be used and the drying and collection areas of the ammonia gas. First, draw a round bottom flask containing ammonium chloride and calcium hydroxide being heated. The neck of the round bottom flask should be to the side and supported with a clamp stand. A delivery tube will be connecting the round bottom flask to a two-compartment chamber seen on screen. Stoppers must be placed in the neck of the containers to prevent any gas from escaping. The top aspect of the chamber is the dryer, containing quicklime, also known as calcium oxide, above a wire gauze. A delivery tube will be connected at the top of the dryer. A glass jar will be inverted above the delivery tube to collect the ammonia gas. D. Ammonia is mainly used in fertilizers such as ammonium nitrate. Explain how nitrate fertilizers can be harmful to the environment. Nitrate fertilizers can be harmful to the environment since they enhance eutrophication in river water. The accumulation of nitrates in the water increases the growth of algae and other water weeds, lowering the amount of oxygen. As a result, there will be a decrease of fish due to lack of oxygen. That's the end of question 6. Thanks for watching. Don't forget to subscribe, like, and share. All the best!